Just take a look around you for a second. The screen you're watching this on, the light bulb over your head, the very internet that's bringing this to you. It's all running on an invisible force we totally take for granted, electricity. Today, we're going to pull back the curtain on the incredible story of how we managed to tame this silent, powerful giant.
So how in the world do we get from a terrifying flash of lightning in the sky to a simple, safe little outlet in our walls? It is an absolutely amazing story, one that stretches back thousands of years. It's a journey filled with curiosity, pure genius, and some pretty fierce rivalries. Let's dive in. All right, Section 1, an ancient static mystery. Our story doesn't start with some big flashy invention. Nope, it begins with a strange little bit of static cling, leading us from a piece of amber to the Greek word electron. So believe it or not, our story starts way back in ancient Greece, around 600 BCE. There was this philosopher, Thales of Miletus, and he noticed something kind of weird. When you rubbed a piece of amber, you know that fossilized tree resin, it would suddenly attract light stuff, like little bits of feather or fluff. Well, the Greek word for amber is electron, and just like that, that simple little observation gave us the word we use today, electricity. For centuries, though, it was really nothing more than a neat party trick. Okay, Section 2. From lightning to batteries. Now, we're going to jump forward, way forward, like 2,000 years forward, into the 18th century. This is when scientists really started to dig into this strange force, and they started to connect the tiny sparks they could make in a lab to one of nature's most powerful and dramatic shows. And that brings us to one of the most famous and, frankly, one of the craziest experiments in the history of science. It's 1752, and Benjamin Franklin has this hunch. He thinks that the giant, terrifying bolts of lightning in a storm are the exact same thing as the tiny little sparks he can create with his equipment. So what does he do? He flies a kite into a thunderstorm with a metal key tied to the string. I mean, can you imagine? As he brought his knuckle close to the key, zap! A spark jumped. He'd done it. He'd proven that lightning was just electricity on a massive, massive scale.
Around the same time, over in Italy, a whole different scientific debate was kicking off, all thanks to a twitching frog's leg. Yeah, you heard me right. An anatomist named Luigi Galvani noticed that whenever he touched a dead frog's nerve with a scalpel made of two different metals, its leg would kick like it was alive. He was absolutely convinced he'd discovered animal electricity, the actual spark of life itself.
But not everyone was buying it. His friend, a guy named Alessandro Volta, was pretty skeptical. Galvani was saying the electricity came from the animal tissue. But Volta had another theory. He thought, hold on a second, maybe the frog isn't the source. Maybe it's just detecting the electricity being created by the two different metals touching each other through the frog's wet skin. So to prove his point once and for all, Volta basically said, fine, I'll take the frog out of the equation completely. And in 1800, he built this thing. He took a bunch of copper and zinc discs and stacked them up, separating each pair with a piece of cloth soaked in salt water. And what he created was the voltaic pile, the world's very first battery. This was a complete game changer. For the first time in history, people could create a steady, continuous, and controllable flow of electric current. Electricity wasn't just a mysterious spark anymore. It was now a tool.
All right, Section 3, the electromagnetism revolution. Now that we had a reliable source of electricity, a whole new world of experimentation just blew wide open. And in the process, scientists stumbled upon something incredible, electricity's secret twin. In 1820, a scientist named Hans Christian Ørsted made a discovery. And get this, it was totally by accident. He was in the middle of a lecture, and he just happened to notice that when he sent an electric current through a wire, the needle of a compass sitting nearby started to move. Just like that, he had proof electricity creates magnetism. Two forces that everyone thought were completely separate were suddenly, undeniably linked. And of course, that discovery immediately led to the next big question, a huge question. If electricity can create magnetism, can you do it the other way around? Could you use magnetism to create electricity? The answer came in 1831 from the brilliant Michael Faraday, and the answer was a resounding yes. He figured out that by simply moving a magnet back and forth through a coil of copper wire, he could generate an electric current. He called it electromagnetic induction. This sounds simple, but this principle is the fundamental basis for almost every single power plant in the world today. It's the discovery that opened the door to generating almost unimaginable amounts of electricity.
Okay, Section 4. And this is where things get really dramatic. The war of the currents, Edison versus Tesla. Now that we could generate electricity on a massive scale, the stage was set for an epic battle over how to get that power into everyone's homes and businesses. So here's the breakdown. In one corner, you had the world-famous inventor, Thomas Edison. He championed direct current, or DC, which is electricity that flows in just one direction. The big problem with DC, though, was that it lost power very quickly over distance. In the other corner, you had the visionary genius Nikola Tesla. He was the advocate for alternating current, or AC, which rapidly switches direction back and forth. Now, AC had this massive advantage. You could easily ramp up the voltage to send it over long distances with very little power loss, and then step it back down to a safe level for people to use. And this battle got nasty. I mean, really nasty. Edison was terrified of losing his entire DC empire, so he launched this vicious smear campaign against AC. He went around publicly electrocuting animals, dogs, cats, even an elephant, using alternating current, all to prove how dangerous and deadly it was. He was trying to scare the public away from what was, frankly, a much better technology. But in the end, you just can't fight physics and economics. The real turning point came in 1893. Tesla and his partner George Westinghouse won the contract to light up the entire Chicago World's Fair using AC power. It was an absolutely stunning spectacle and a massive success. Then, shortly after, they built the first major hydroelectric plant at Niagara Falls, sending AC power all the way to the city of Buffalo. And that was it. The war was over. AC had won, and it became the standard for the entire world.
And that brings us to our final section, from amber to the internet. A world illuminated. Because once AC won, the floodgates opened. The modern world as we know it was born, built entirely on the back of this incredible electrical grid.
I mean, just look at the timeline. After AC's victory in the 1890s, the 20th century gave us the transistor in 1947, which kicked off the entire electronics revolution. That led to computers, which led to the internet going public in the 90s, which ultimately led to the powerful supercomputer that you're probably holding in your hand right now. It's just wild to stop and think that this entire world-changing revolution, from massive power grids to the smartphone in your pocket, it all started, all of it, with a philosopher in ancient Greece getting curious about why a little piece of fossilized tree resin was picking up feathers.
That whole incredible journey, it all began with a tiny spark of human curiosity. And it really makes you wonder, doesn't it? What's the small observation, the little spark of curiosity today that might just light up our entire future?